So we're looking at operations with polynomials day 2. In order to look at that, we're going to start by reviewing some of the ideas, concepts, etc. that we talked about yesterday. So in order to do that review, I'm going to have you do 1 through 8 at the top as a warm-up. All right, let's talk about and go over the warm-up. So in number 1, 2, and 3, we were simplifying. So you simplify by combining like terms. Like terms are variables and numbers that are the same. So in that first one, you did 12 divided by 2 to get 6. The 6 stays on top because the 12 is the larger of the divisors. X to the 4th over x, you subtract top from bottom, so 4 minus 1 is 3. And same with the y's, it's top minus bottom. 2 minus 5 is negative 3. So y to the negative 3 drop to your denominator as a positive y to the 3rd. In number 2, the cube distributes both to the numbers and the variables. So 2 cubed is 8, 3 cubed is 27. So that's where the 8 over 27 came from. And then 2 times 3 gave you a to the 6th. And b cubed. No like variables, so we cannot simplify any of the variable terms. And in the last one, that cube distributed to all 3 parts. If you have it distributed to variables, you multiply. If it goes to a number, it becomes a power. So 6 cubed is 216. 5 times 3 is 15, and negative 4 times 3 was negative 12, which dropped to the denominator as a positive 12. Okay, is it a polynomial? If yes, state the degree. The first one is a polynomial. That's a linear expression, so that is yes, degree 1. The second one is also a polynomial. It is yes, degree 2. And the last one is no, because it contains a radical, and a radical makes it non-polynomial. Okay, and then in 7 and 8, we were combining like terms. So in number 7, you had to distribute your negative to both parts of that inside the parentheses, thus changing all of the signs, giving you negative 2x squared minus 6x plus 3. And over here, we just grouped together a and b, and you got 9a minus 2b. Okay, so what we're going to do today is talk about different properties from the past. So the first property we're going to talk about is using the distributive property to distribute to a trinomial. So what that means is we are distributing that 3x to all three parts. And then we're going to talk about how it changes the values of the exponents. So 3 times 2 becomes 6. X times x squared, you add the exponents when you multiply, so you get x cubed. You multiply the coefficients, so 3 times 4 is 12, and x times x is x squared. 3 times 6 is 18, and x. No like terms, so you're done. And then in number 2, you want to distribute the 4/3 x squared. So the 4/3 is going to multiply to each coefficient, and the x terms are going to multiply as well. So in that first one, 4 times 6 divided by 3. Well, you can either multiply the top numbers, then divide by 3, or you can say, okay, 6 divided by 3 is 2. 4 times 2 is 8. And x squared times x squared becomes x to the 4th. And then in the next one, 9 divided by 3 is 3. 3 times 4 is 12. X squared times x is x cubed. And then minus 12 divided by 3, which is 4. 4 times 4, which is 16, x squared. So this is a 4th degree polynomial. So that would be degree 4. And then we use the distributive property with word problems. It says the U.S. Department of Transportation limits the time a truck driver can report between periods of work to rest to 10 hours. For the first part of his shift, he drives at a speed of 60 miles per hour. And for the second part of his shift, he drives at a speed of 70 miles per hour. Write a polynomial to represent the total distance driven. So he can work for a max of 10 hours. He's driving at 2 different speeds where his total time driving is 10. So what we're going to do is say that his number of hours driving is represented by x. So he might drive at 60 miles per hour for x numbers of hours. And then he drives for 70 miles per hour for 10 minus x. So if x is 4, he does 4 hours at 60. And then here, 10 minus 4 would be 6. So that would be 6 hours at 70. So that setup allows us to create a speed and analysis for his time driven. If you distribute and multiply and add all of that out, then he's negative 10x plus 700. So what that tells us is that he drove at least 700, or at most 700 miles, because that would be driving all 10 hours at 70 miles per hour. So the max he could drive is 700, and then what we do is subtract from that the distance driven at 60. You can multiply polynomials with binomials using two different methods. So we're going to talk today about the FOIL method and the distributive method. The FOIL method kind of goes by another name if we have more than two terms. So we use FOIL if we are multiplying a binomial times a binomial. So that's where you have the case of like A plus B times C plus D. So A plus B is considered a binomial and C plus D is considered a binomial. So what happens is FOIL, that first, outer, inner, last, doesn't work if you have more than two binomials. So we use what we call the distributive method. Sometimes we call it the FML method, where it stands for first, middle, and last. So you're going to distribute to the first, middle, last, and the first, middle, last. So that's the method that we would use in this case. So we're going to use that first, middle, and last technique. And we're going to take the n, and we're going to take it to the first term, the middle term, and the last term. So n times n squared is n cubed. N times 4n is 4n squared. And n times negative 6 is negative 6n. So we first, middle, last with the first term. Then we're going to do that again. So you're going to take the 2 to the first, 2 to the middle, 2 to the last. And then this is where the stacking technique sometimes comes into play. So 2 times n squared gives you 2n squared. So I can stack that 2n squared under my already n squared term so that I can add up these terms vertically. 2 times 4n is positive 8n, and 2 times negative 6 is negative 12. So what we're going to do is add the terms vertically and combine the like terms, which are the two terms in the middle. So you get n cubed plus 6n squared. Remember that adding combined like terms does not change the powers of the variables. It only adds the coefficients. And then plus 2n minus 12. So that's technique number 1. Technique number 2 is known as the box method. Sometimes in Delta Math, you've used the box method with their foiling problems, where they had you drag in the parts of the problem and then you multiplied into those boxes and you filled them in. So what you didn't realize was that you were using this new technique known as the box method. The box method should also remind you of the multiplication table that you learned in like 3rd grade, where you had like 1 through 12 up top, 1 through 12 on the side, and then you could pick any two parts and that gave you the numbers multiplied. So if that was like 2 and 5, then the number here inside the chart was the number 10 because it represented 2 times 5. So way back in the day, that multiplication chart is actually an introduction to using the box method to multiply. So what we're going to do is simply multiply these together. So x squared times x is x cubed. 4x times x is 4x squared. 16 times x is 16x. X squared times negative 4 is negative 4x squared. 4x times negative 4 is negative 16x. And 16 times negative 4 is negative 64. In the box method, you always add the diagonals together. So the way the box method works is the diagonals should end up being your like terms. So you have x cubed that stays. It has no other like term. Then you add these like terms together, and a negative 4x squared and a positive 4x squared cancel. A negative 16x and a positive 16x cancel. And then we have minus 64. This type of problem, this x cubed minus 64, actually has a special name. This is called a difference of cubes. And as we factor polynomials, we're going to learn about like we had difference of squares, we're going to learn about a formula called difference of cubes, where the first term and the last term are both cubes, and they factor a special way. So again, that's just a hint at where we're going. The easiest way to get good at these two methods is to practice them. I do not care which method you choose to use. So on your homework, you're looking at 30 through, I believe it is 50. So for your homework, you're looking at 30 through 50. It actually ends up being over the course of 3 pages in that notes guide packet. So we have about 20 minutes in class today, so you have a lot of class time to work on that. If you get stuck, you can ask questions. These problems require you to show work, so when I'm looking at this homework that's due on Monday, I'll be looking for work. If you don't want to do it on this handout, you are gladly welcome to use notebook paper as well. But again, make sure you show your work and steps, and you can begin working on that homework now.